Assalamualaikum warahmatullahi wabarakatuh. I'm Dhiyannisa. Good morning, ladies and gentlemen. I will explain about LTE architecture. LTE architecture is known as evolution of system architecture, which discusses architectural renewal compared to previous technology. Overall, LTE supports EPS or Envelope Packet System technology. Although it is marketed as 4G technology, LTE which is marketed now cannot be referred to as 4G technology entirely. LTE which is set by 3GPP on release 8 and 9 doesn't meet the ITU or organization standardization. LTE advanced technology is certain to meet the requirements to be referred to as 4G technology. So in LTE have three important components. They are first is user equipment, two EUTRON or envelope UMTS terrestrial radio access network, and three EPC or envelope packet core. First, user equipment. User equipment is a device in LTE which is located at the far end and is close to the user. The destination of the UE on LTE is no different from the UE on UMTS or previous technology. There are two components in the user equipment section, which is mobile equipment, which is a radio signal receiving and transmitting device or commonly known as phone, and new SIM or UMTS subscribe identity mobile, which is a customer identity card to be recognized by the network. So to see the component of the user equipment, you can see in the following figure. The second of component, this is an EUTRON. Envelope UMTS terrestrial radio access network or EUTRON is an LTE architecture system that has the function of handling the radio side access from the user equipment to the core network. Different from the previous technology, the supports not B and R and C into its own elements. In the EUTRON LTE system, there is only one component node, namely envelope node B or E node B, which has combined the function of both. E node B basically is a base station located on the surface of the Earth, or BTS ground or placed above buildings, or BTS rooftop. To see the components of the EUTRON, you can see in the following figure. The last important component in LTE architecture is a envelope packet core or EPC. EPC is a new system in the evolution of the cellular communication architecture, a system where the core network uses all IP. EPC provides mobile core functionality with its previous generation 2G and 3G. Has two support namely circuit switch for voice and packet switch for data. EPC is very important for end-to-end IP delivery service on LTE. In addition, it plays a role in enabling the introduction of new business models, such as content and application providers. EPC consists of MME, Mobility Management Entity, Serving Gateway, next Home Subscription Service, the next Policy and Charging Rules function, and Packet Data Network Gateway. Here is a brief explanation. First, Mobility Management or MME. MME is the main control element in EPC. Usually, MME service at the operator's security location. Operation is only in the control plane and doesn't include user plane data. The main function of MME in the LTE network architecture are authentication and security, mobility management, managing subscription profiles, and service connectivity. The second is home subscription or home subscription service or HSS. HSS is a customer data strong for all user permanent data. The second, home subscription service or HSS. HSS is a customer data strong for all user permanent data. HSS also stores the user's location at the level visited by the network control net. Like MME, HSS is a database server that is centrally maintained on the premises home operator. Third, Service Gateway or SGW. In LTE network architecture, the highest level of SGW's function is a bridge between management and switching user plans. SGW is part of the network infrastructure as an operational and maintenance center. The role of SGW is very little in the control function, only responsible at its own search and allocate it based on MME PGW per CRS requests, which is requested of a modifier or clarification of the user equipment. Fourth, Packet Data Network Gateway or PDN-GW. Similar to SGW, PDN-GW is an important component of LTE to terminate with a Packet Data Network or PDN. The PDN-GW supports policy enforcement features, packet filtering, charging support on LTE. Data traffic is carried by virtual connections called Service Data Flow. Fifth, Policy and Charging Rules Function or PCRF. PCRF is part of a network architecture that collects information from and to the network, operational support system, and other sources such as portals in real time, which supports the formation of rules and that automatically makes policy decisions for its active customer on the network. Networks such as this may offer several service, quality of service, and charging rules. PCRF can provide wireline and wireless network solution and can also enable a multidimensional approach that helps in creating profitable and innovative platforms for operators. PCRF can also be integrated with different platforms such as billing, rating, charging, and customer base, or it can also be used as a standalone entity. To see the components of the EPC, you can see in the following figures. So what the LTE is superiority? First, when the connection to LTE is low, the signal can be transferred to other technology networks such as GSM. LTE has spectrum between 1.4 MHz to 20 MHz. Second, on the transmission side, LTE uses ST-FDMA for uplink and off-DMA for downlink, which can be more efficient in energy use. Third, from the user side, many interesting services are offered such as VoIP, live TV broadcast, and others, and can optimize services such as MMS, email, anti-delay browsing. So next, we will look at the complete LTE architecture with interface. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.